Hey everybody, Mr. Bucko here with the problems from your Algebra Chapter 10 practice test. This video will do Algebra Skill 38 and 39 from your practice test. On the screen I have Algebra Skill 38, where we are supposed to solve this system of equations by graphing. So we have the first equation here, y equals 3x plus 2, which is in slope-intercept form, and if an equation is in slope-intercept form, we can graph that equation by using the y-intercept and the slope. And by looking at this equation here, I know that the y-intercept of this equation is 2, because y equals mx plus b, where 2 is in place of b, so 2 is the y-intercept. So I'm going to plot that on the graph, which is right there. Our y-intercept is right here, because this is where y is equal to 2, which is our y-intercept. Then we're going to use our slope, which is 3. And it'd be nice if slope was a fraction. 3 is not a fraction. So to make it a fraction, we're going to go 3 over 1. So from our y-intercept, we're going to go up 1, 2, 3 over 1. And this is another point on the line. We can do it again. Up 1, 2, 3. Let's try that again. 1, 2, 3, and over 1. There's another point on the line. The line that goes through all three of these points looks like this. So this is the line for the equation y equals 3x plus 2. Now we're going to graph the line 3x plus 3y equals 18. Notice this equation is not in slope-intercept form. This equation is in standard form. So what that means is that I do not know what the slope or the y-intercept of the line is for this equation. But since it is in standard form, I can find the x and y intercepts relatively easy, at least easier than finding the slope. So I'm going to plug in 0 for y to find out what our x-intercept is. Because if I'm looking for the x-intercept, the value of y has to be 0. So if I plug in 0 for y here, then this 3y goes away, because 3 times 0 is 0. So this is completely gone if I'm looking for the x-intercept. So then I'm left with 3x should be equal to 18. Well, if 3x is equal to 18, then x has to be 6. So therefore, the x-intercept of this equation is 6, which means that the line for this equation crosses the x-axis at 6, which would be 1, 2, 3, 4, 5, 6. Right there. Whoops. Well, it should be moved over just a little bit there. My mistake on that graph. So 1, 2, 3, 4, 5, 6. Moved over just a little bit there. And then the y-intercept will be the same thing, because now I'm going to plug in 0 for x, and our y-intercept will also be 6, because if I make x 0, this goes away, and I have 3y equals 18. Therefore, our y-intercept is 1, 2, 3, 4, 5, 6 right here. Draw the line that goes through those 2 points, and do that very well. Another reason I don't like graphing too much. And we find that the solution is where the lines intersect, and it appears that these 2 lines intersect at this point. It appears. If our graph goes wrong, then that could be a problem. So it looks like that point is 1, 5. It looks like it's 1, 5. So to check if my answer is correct, what I'm going to do is plug in x for 1 and y for 5 into each of these equations. So I get 5 equals 3 times 1 plus 2. I just plug the 1 and 5 into this equation, and I get something that makes sense, because 5 is equal to 3 times 1 plus 2. And if I plug it into the bottom equation, 3 times 1, which is 3, plus 3 times 5, which is 15, is equal to 18. So despite my subpar graph here, 1, 5 is the answer, because that is where these 2 lines intersect. So let's talk about a more efficient and sophisticated and precise way to solve systems, and that's with Algebra Skill 39, where we will not use graphing, we will use substitution. So we have y equals 3x plus 1 and y equals 0.5x plus 4. So what I'm going to do is, since I know that both of these equations are equal to y, I can set them equal to each other. If 3x plus 1 is equal to y and 0.5x plus 4 is equal to y, then they must be equal to each other. And now I can solve for x because I have just one variable. So what I'm going to do first is subtract 0.5x from both sides of the equation to get rid of this thing. 0.5x, I want this gone, so I'm going to subtract it. And if I subtract it from the right-hand side of the equation, I have to subtract it from the left-hand side of the equation, which is where this 2.5x comes from. Then we have plus 1 equals 4. Now I'm going to subtract 1 on both sides because I want this plus 1 gone so I can solve for x. So by subtracting 1 on both sides, we have 2.5x is equal to 3. And now since 2.5x is equal to 3, I'm going to divide both sides by 2.5 and get 1.2. X is equal to 1.2 because 3 divided by the 2.5 over here is equal to 1.2. But I'm not done. I'm going to take that 1.2, plug it into the equation, and get 3 times 1.2 plus 1. I'm taking this 1.2 and I plugged it into the top equation right here, because now that I know the value of x, I can do that. 3 times 1.2 plus 1 is going to be equal to 4.6. So the solution to this system is going to be 1.2, 4.6. If I was to graph these two lines, these two equations, or these two lines, would intersect at the point 1.2, 4.6. Another good reason not to make a graph, because I would not be able to identify 1.2 and 4.6 by looking at a graph, and even if I was close and tried to plug that in, that might not work out too well for me. So 1.2, comma 4.6 is the solution to this system, and we used substitution.